Welcome. This is a sample system which serves a ML model using FASTAPI within a Docker container, which relies also on Redis in order to take the load off of the API server. In addition to that, there's a Flask UI which consumes the API service, so we have an end-to-end solution. We're running all of this within Kubernetes, and we are also using Prometheus and Grafana in order to show the activities which are happening within that cluster. So let's get right to it. This may seem a little bit daunting, at least it did to me initially, but once we peel the onion, it starts becoming more understandable. So this is our FastAPI container, which we're serving on port 8000. We have our Flask container, which we're serving on port 500, and our Grafana. So let's look at these one by one just to demystify it. This is it. We've got our Swagger UI. I'm going to go ahead and invoke the cache ratio method. And this is pretty neat. We've got 78,000 requests into the system so far. 80% of them pretty much are cached. This, moving forward, is this service here on 5,000. And what this is it's consuming the ML model which is being served from this Swagger UI. So there's a connection here, as you can see, where this is consuming that service. Finally, we have Grafana. Let's have a look at this. And Grafana is serving up our dashboards, and we have our service dashboard, 9 panels. So you can see these are our requests coming into the system. We see how they're being served. Let's look at our client workloads, right? And let's look at our workload dashboards, general, very similar. And so this sort of demonstrates what's going on with the system. So that, in a nutshell, is the system. There's a lot under the covers. What we're going to start with here are the prerequisites. There are quite a few. And so in order to make this easy, we've created a script which will install all the dependencies. And then if we want to run this system from scratch, we're going to go ahead and experiment with that. We've created this, and what this does is it pulls it down from the repo, and it just spins up the entire system from scratch, creates all the images, creates everything that you need, and then says it's ready. So let's go ahead and do that. We've pasted this command in. It's going ahead and cloning, and then it's going to begin building the entire solution. This is going to take a little time, so let's pause it. But before we do that, let's just look at this particular call here. So you can see we're using Poetry PyTest. This tests everything ahead of time so that when we build our containers, we know that our API is rock solid. A little further into our build process, you can see here that the pods have come up, but we're waiting for them to all be available within the cluster before we're able to commence load testing. Alright, so finally it tells me that all of the sites are ready, so what we're going to do is pop back into here, and whereas these were prior down, they are now up again. Or are they? Yes, they are. And then here is Grafana. There's probably not a lot in these dashboards because it has just begun to come up. So yeah, there'll be a smattering of requests, but not a lot. This will begin to flush out as more requests come into the system. So that is how we start the system running from scratch, and as you can see, we've got our happy results, and we can look at each of these. We have to put docs in here. We can look at each of these and see that they pull up properly. And we can monitor our load testing if we want. What happens when this thing starts up is it actually does begin a load testing routine in the background. You can see that call being made within the run.sh, so there's a call to that inside of that. And then while this is running, as we mentioned, we ought to be able to come in here and look inside of our dashboards, and we see that things start ramping up. All right. And then there's one other thing which we've incorporated in here, and that's this GitHub Actions. So we spoke for a minute before about the complicated deployments or the dependencies. So we're testing the setup of these dependencies inside of a Linux container, and this happens every time we do a pull request. And using this basically has the effect of guaranteeing the quality of our code. There's a lot of complicated GitHub Actions and hooks and what have you. This is pretty simple, but it really does serve a good purpose in terms of letting us know if our deployment is healthy or not. This is an example of one that failed. I forced a failed condition, and then this works. Finally, if we want to tear down our system, we go here to this, and we just wait for the load testing to complete. Let's wait. Alright, so here we go, and we can see from our control panel that the load testing is finished, and we can also see from Grafana that our load testing, basically we had this ramp up, this ceiling, and then everything shut down. So that's kind of in keeping with how we set up K6. We can then do Control C as it says, and then we can tear down the system, and it clears everything out. And once that's done, these dashboards should disappear. So let's give it a second. So as we can see here, the teardown is complete, and if we go back here, we've got nothing. I mean, I think this is, all of these will have died. So that concludes this demonstration of the system end to end. There is, I think, quite a lot more to talk about in the system in terms of the caching and how to train the model and all of these things, but that should be, I think, available within the code if one reads it. But this is an overview of showing how you can spin it up, how to manipulate it, what it does, how to install the dependencies, and how to get some utility out of it. Thanks for joining us.